Good morning from the Rooster Inn Observatory. This morning I'm going to compare Seestar to Dwarf when it comes to their solar modes. So stand by as I get things ready. Yep, first of all, it is for Seestar. I installed the filter and let's see if it's gonna find the sun on its own. It is looking for it, that's for sure. Nope, it passed through. Let's see if it's gonna come back for it. It found it. It came back to the sun. That is good. That is a good start. Is the sun in the center? Yes. And that's my big test as to who's going to track more accurately. In the meantime, Dwarf does not have the ability to seek the sun, but we can do so manually. And there is the sun in this case. I'm going to move it to the middle. And I'm going to select as feature sun. And confirming that we have the filter on. For some reason, Seestar is already losing the sun. It's drifting. There are some solar spots that I'm anxious to look at. Nope, come back, please, come back. All right, stop here. Yes, we are in the middle. Don't go anywhere. And let's focus. No, that's not what I had in mind. Oh, nice. Okay, autofocus. In the meantime, let's adjust the gain to something more reasonable. Dwarf Lab recommends 1/200. I'm going to go with 1/200 for now. And let's focus it. All right, there we go. For the fairness and the fun of the comparison, I'm going to enlarge the Dwarf a little bit. The sunspots are a lot more visible on Seestar, obviously. And they are here on Dwarf. Let me capture a video in each case and see what we can do with them. Good morning, Dan. We're doing well. We're looking at the sun this morning. I am putting Seestar and Dwarf side by side to look at the sun. I have to decide which one I will use for the solar eclipse come April. Earlier today, I looked at the solar flares using my Lunt LS50, solar prominences. Some people will yell at me if I call them flares, and there were quite a few of them. They looked good. All right, I captured a minute of each, and I'm gonna zoom in. And then turn off all the legends. So Seestar is showing quite a few of the sunspots. Let me see which sunspots these are. According to NASA, and they named them, we're looking at 3490, 3491, and then 3489. So the lowest one is 3489, and the other two are 3490 and 91. So might as well label them. Now, another interesting feature of Seestar here is the time lapse. What is my time lapse? All right, there's time lapse on the other side. And if we go time lapse, it allows us to choose how often or what intervals we're going after. I'm going to go for the fun of it with 1 minute time lapse and see what we get. And off you go. So it's going to take 1 frame every minute. That is not going to be a good test for the solar eclipse because the eclipse will, totality will only last 3.5 minutes. But my big test this morning, and I'm going to spend about the better part of an hour here to see which of the two telescopes is going to keep the sun within its field of view the longest. When from the time the eclipse begins till the time the eclipse ends on April 8, let me see how much time we will have total. We're going to have just about 2.5 hours. It starts at 2:09. That's when the moon starts covering the sun, and ends at 4:35. That's when the moon leaves the sun alone. So a 2.5 hour a time lapse. Or what do we want it to last? 2.5 minutes possibly. So we'll be taking 1 frame every minute, which is what I'm trying to do now. With the big, however, the totality itself is only 3.5 minutes. And I don't know at this point whether I will remove the solar filters or not. When I say I have to decide between Seestar and Dwarf, I think my decision has been made for me, as in I'll take both and have them both staring at the sun. I will have my Lunt LS50 hydrogen alpha to look at the possibility of solar flares shooting out of the sun around the moon. So there is Seestar showing that has taken 2 frames so far. I need to do something about the dwarf's focus again. Well, it's trying to do its best. It is rotated by 90 degrees, and these are 3490 and 3491. The question is, welcome back, Dan. The question here is, yes, right on top we have 3490 and 3491, and then down here is 3489. I don't know if zooming further is going to help us at all. Yeah, they're trying to look nice. I'm going to see if focusing manually will help matters. Nope, this is going in the wrong direction. No, it's not helping at all. Back to autofocus. In the meantime, the autofocus of Seestar has been spot on with the ability to zoom in and to look at the sunspots. Okay, they are about the same size now. So far, I can say both are tracking the sun perfectly. Seestar had a hesitant start, but now it is good. The solar filter, the neutral density filter, is a lot nicer on the Dwarf than it is on the Seestar. On the Dwarf, it is glass, whereas on the Seestar, it's a mylar film of some sort, and many people have complained that they have pushed their fingers through it and ruined it. The filter holder on the Dwarf is a lot nicer than the one on Seestar. Dwarf has a metal holder in which you screw the filters and then it attaches to the scope magnetically. So taking it off and putting it on is a very easy. In the case of Seestar, it's a plastic rim that you have to squeeze into a plastic holder, and then you have to rip it gently without jerking either the filter or the scope. If only Seestar had put some metal in the front of the scope and used a magnet of some sort to attach the filter, that would have been a lot nicer. Which is essentially what the Dwarf did with theirs. So we are testing the Dwarf time-lapse in addition to the Seestar time-lapse to compare them. And it appears that the sun is drifting in the Seestar field of view ever so slowly. I would think that seeing it photographically, it should be able to track it. The Dwarf seems to be doing much better in this case. It is locked onto the sun and tracking the sun. So I took 10 frames at 1 minute intervals, time lapse. I'm going to do the same with Dwarf and then compare notes later on. I don't know whether I need to jerk the sun back in manually or whether it'll do it on its own. So far in doing the quick comparison between the two scopes when it comes to solar observing, uh, item 1, Dwarf has a nicer filter holder, glass filters. Number 2, Seestar found the sun without trouble. 3, Seestar focus it focused better on the sunspots. Both of them took time lapse, and the big test in my mind remains drifting. We have been live for over 20 minutes now, and it's looking like for the tracking test, the Dwarf is doing better than Seestar in this case. Smack in the middle. Let me show you if I go back to video mode. Come on. Oh, that's right. It's still. I have not stopped the time lapse. It needs another couple minutes. I asked it to take 10 frames at 1 minute intervals, which we did earlier with the Seestar as well. I don't know if it's going to let me do some coloring here. Nah. Okay, we'll wait for the time lapse to end and then add some color to the dwarf image. Now I need to drag Seestar, drag the sun back to the center. And then sync it again. Another 40 seconds and Seestar will be, Dwarf will be done. Let me show you something else that Seestar has that, or it looks like the focus is starting to suffer. It certainly is. Let's do the following. It doesn't want to let me move it. Ah, yeah, that's why. I was just trying to put the sunspots in focus or in the field of view. Hold it there for a minute. Don't move the sun around. And let's re-autofocus. And here we go. Unfortunately, Dwarf does not want to give me better focus. Alright, this basically matches colors for us, if there is an interest in matching colors. I shall attempt manual focus one more time, see if we can get a sharper view of the of the sunspots. Nah. Alright, auto again. That's the best we're getting today. So in summary, the sky is obviously turbulent. Seestar is having trouble keeping the sun within its field of view. I have not had to adjust the location of Dwarf, so Dwarf is tracking the sun a lot better than Seestar. Dwarf does not have a go-to ability to the sun. I had to find the sun manually. The filter on the Dwarf is much better than the filter on the Seestar. It's glass and the holder is metal. On the Seestar, it is a mylar film of some sort and the holder is plastic. The focus on the Seestar is far superior to that on Dwarf this morning. Both are able to take time lapses and the sun is drifting still. But we can certainly see the sunspots a lot more clearly on Seestar. I took a video on the Dwarf. I took videos on both actually, and I will stack them to see if it'll make a difference. But that is the feature that I want to point to you on Dwarf. If you select Sun, it will track the Sun, which it is doing very, very nicely this morning. And in the interest of full disclosure, I did zoom in on the Dwarf to make the Sun about the same size as that on the Seestar. But if we go back to native, that is what the Sun looks like given the 3-degree field of view versus 1-degree field of view. The Sun is about 30 minutes, about half a degree. Arc minutes, arc degrees. Earlier this morning, I used my Lunt LS50 to look at the prominences. If you have not seen the video, please do. The Sun is particularly active this morning with solar prominences both on the west limb and the south pole. If the weather permits, I'll come back and take pictures. I'll come back and image sunspots 3490 and 3491 and watch them as they travel across the sun over the next 10 days or so. The sun makes one full revolution around its axis in 25 to 26 days. And being a ball of gas, it moves at different speeds at the poles than it does at the equator. But yesterday, 3490 and 91 were not visible. If you have not seen Seestar in action in terms of fighting the sun, let me see if I can demonstrate it. We're going to turn off tracking. Time lapse is no longer an issue. We're going to go, okay, come on, the photo, and I'm just going to go to solar. Let me get the sun out of the way first. It says install the solar filter, which we did, installed and shooting, and it's going to try to find the sun. And that's how it finds it. It centers it nicely, asks if it's on the screen, yes. So what I'm going to do now is I'm going to move the sun completely out of the screen. It's gone. And we're going to see if Seestar can find it. Not bad. Not bad at all. But this is where I'm surprised. It is able to center it, and we'll let it synchronize to it and track it. And that's where it is drifting. I cleaned the lenses and the filters on the Dwarf before we started. Good morning, Bill. The sun does a full revolution around its axis in 25 days. So we're talking about 10 or so days to go from one end to the other. I suspect if we take a snapshot every minute or so and let it run for a couple hours, we will notice movement. Good afternoon, Ken. The main purpose of my exercise today is to choose which of those two telescopes will travel with me on solar eclipse day, April 8th. I will have the Lunt hydrogen alpha scope, but I'm trying to see which one of these will complement the Lunt. And right now, I know the answer. It's going to be both. The first time Seestar found the sun this morning, and it locked on it, it drifted out of the field of view within seconds. The second time I sent it back and found it and locked it. It drifted a lot more slowly. It took about 15-20 minutes before it started coming near the edge. This time it seems to be staying still. A dwarf, on the other hand, as soon as I turned on the sun tracking feature, it locked on the sun and it has not moved from the middle of the screen. But for some reason, Dwarf is unable to resolve those sunspots. I mean, they are there. Please note the 90-degree rotation that I did on the Dwarf. So what is the east limb is up here in the case of the Dwarf. And every attempt to focus, it's trying to focus. The sunspots are there, but not as sharp as on the Seestar. Let me verify that I have binning turned off. I'm pretty sure I do. Yeah, binning is turned off, so that's not the issue. I don't know what the issue is. We don't have a problem of condensation, obviously. It's warm enough outside. Well, warm. We are below freezing. But it's all relative. So that's all I have for this morning. I'm pleased to say now that Seestar is no longer drifting. I don't know if it's a matter of moving it a couple of times for it to loosen up. The sunspots are slightly more visible on the Dwarf now. They have the same sensor resolution. Granted, Seestar has 4 times the aperture surface, twice the aperture as Dwarf, but that should not matter when we're looking at very, very short exposures, 1/200th of a second. I don't know if changing that's going to make any difference. Not really. Let's change it in the other direction. I mean, they are there. I can see them. And if we blow up the screen, they are there, but not as clear as the Seestar. So, ladies and gentlemen, I'm going to wish you a good rest of the day, and let's see what the night brings, if we're going to be up tonight or not. I have a few targets I'd like to go after, not the least of which is M104, the Sombrero Galaxy. I'd like to put a few hours on it with all three telescopes, Stellina, Seestar, and Dwarf. And so we see what we get. I also want to do globular clusters, M13 preferably, and compare the three scopes and see who does what. In the meantime, so long from the Rooster Inn. I'm gonna go grab lunch and try to be productive.